All right. Can you guys stop talking, please? Thank you. Today, we're going to start with some questions. You guys should have done a little bit of solving over the weekend on the homework 1 from chapter 2. If anybody has questions about that, we'll start by taking some of those. Bianca?
This is kind of just like a general question for like 16 to 25.
Okay.
If it's like equal to negative, it's already no solution. But what if it's like on the other side of the, like greater or less than it's negative, and some on the other side of the negative?
So you're saying like this? Oh, sorry.
No, it's okay.
It's okay. Okay. So you mean something like this then, Bianca, where you have the absolute values greater than some negative?
Mm-hmm.
That's fine.
That's fine. So
Mm-hmm.
like to solve it.
Mm-hmm.
Oh, okay. Because I think I just made that mistake, and for every single one that I saw was a negative, I just put no whatever instead of just solving it out. Okay.
No problem. Good question. Who else has questions? Stefan. Sure. This has no solution. I can immediately tell that because there's no absolute value that can give me something less than a negative. Okay? So again, maybe not totally obvious right from the look, but if you think about it for a moment, we know that an absolute value can't give you a negative value. So if you want something less than a negative, that certainly can't happen. You know what I mean? And Drew?
Yeah. So are no solutions in 0?
No.
So 0 is
A 0 is a solution. Like x equals 0 is a number. That's an answer. No solution means there are no answers to it. Oh, sure. Zeros, yes, having no solutions is the same thing as having 0 solutions.
That's what you wanted to add.
Hallie. 20, sure. All right. So I'll start by adding 5 to both sides to get the absolute value part by itself. And then we'll split this into 2 equations, or I should say inequalities. I have to remember that when I make the one answer negative, I have to remember to flip the inequality symbol. And I'll solve each of these inequalities separately, so I'll subtract 2. And then we'll multiply both sides by the reciprocal, which is the same thing as dividing by 1/7. So I'll multiply by 7. So x is greater than 42 is that. X is less than negative 70 should be that. So this would be an OR inequality. Is that okay, Hallie? Sure. Ben?
Yeah. You do number 9.
Number 9? Yes. So the first thing we'd want to do is to get the absolute value part by itself, but that's already done for us. So we'll split this into 2 equations. Where we just drop the absolute value from the first one, and the second one we drop the absolute value and we make the other side negative. Now we'll just solve each of these 2 equations separately. So we'll start by adding 6 to both sides. And then dividing by, you could divide birds, but what I think is probably easier is to just multiply by the reciprocal. So multiply by 3 over 2. And to multiply fractions, think about 18 is 18 over 1, and negative 6 is negative 6 over 1.
Go back. How can you multiply?
It's the same thing as dividing by 2/3 is multiplying by a reciprocal. Dividing by a fraction and multiplying by its reciprocal are the same thing. So that's why I did it that way, because it's easier to do by hand. Right? Like dividing by 2 and multiplying by a half gets you the same answer. Is that cool? Okay. So to multiply 2 fractions, Ben, we multiply straight across. Or what I think would be easier would be to reduce first. So I noticed that 2 goes into 19, or 18, excuse me, and 2 goes into negative 6. So we have x equals 9 times 3, and then x equals negative 3 times 3. And you check both of these answers, but both are going to work. Okay with that? Okay. Who else? Are there others? Andrew? 20. Okay. So the first thing I'd want to do is to isolate the absolute value, but that part's already been done for us. So I can go ahead and split this into 2 pieces. The first piece, I just drop the absolute value symbol. And the second piece, we negate the right-hand side and also flip the inequality symbol. So now I'll just start by subtracting 16 from both sides. Okay, and then we have to divide both sides by negative 1. We divide by negative, we have to remember to flip the inequality symbol. Okay with that? And now we'll graph to just see which one it is, whether it's an AND or an OR. So less than or equal to 13 is here, and greater than or equal to 9 is here. Since the arrows point away, that's the OR inequality. Alexis, you're welcome. 17. Yup. Yeah, of course. You don't ever have to ask. If you can't see, turn them off. Okay, so just like the last one, we're going to start by trying to isolate the absolute value, but that's already been done for us. So let's split this into 2 inequalities. The first inequality, we just drop the absolute values. the second inequality, we negate the right-hand side and have equality symbol. And then we just add 2 to both sides. I'm going to finish it up in case there's anyone else still that wants to see the end of it. And then now we graph each one of these. So -5, +9. So x is less than 9 is here, and greater than -5 is there. So this should be. Alternatively, you could have also written your answer like this. Acceptable as well. Any last takers on questions before we move on? Allie?
This is kind of stupid, but you know where it says and, does it matter which one?
No. Does not matter which inequality goes first. Jack? Uh-huh. So first thing we'd want to do is to get the absolute value by itself. That's already been done for us, though. So we'll just split this into 2 equations. So one where I just get rid of the absolute values, and the second one where we negate the right-hand side. Now we're going to just solve this as we would ordinarily. So I'll subtract 8x from both sides, and then divide by -2. This one will subtract 8x from both sides and divide by -14. But we have to check this to see. So probably the easiest way to do that is just to use our calculator, particularly since this involves fractions. So to check this, all I'm going to do is I'm going to type in the right-hand side, or the left-hand side, and then the right-hand side separately and compare the 2 answers to see if they check out. So to get the absolute value simple, I press the math button. I go over to this number menu, and I'll select the ABS command. I have 8 times, and to get the 1/2, one way you can type a fraction is if you press alpha and y equals. This is a shortcut to the fractions menu. And the one that we want is the n over d. That just makes the fraction just like you're used to, or like is written on your sheet of paper. And then the -1. So I press enter, I get 3. And then 6 times, and then I'll do the fraction command again. And I get 3, so this one works. Let's check the other one right quick. So math, number menu, absolute value, 8 times, and then alpha, y equals, n over d, and I'll type in 1 over 14, then -1, and press enter. Then I'll do 6 times alpha, y equals, n over d, 1 over 14. And that one worked as well. Okay with that, Jack? Okay. So let's start today. So today we're going to start talking absolute. And we're going to start this by referencing some stuff that had happened last chapter. So there's 2 big ideas from last chapter that we're going to use in order to kind of develop a system to do this. Okay. So from last chapter, in the last section, we talked about transformations. And one of the big ideas we had that was any transformation of a function can be written in the form, oops, supposed to be an F there, a times f of 1 over b times x minus h plus k. Now in this chapter, our function that we're interested in is just the absolute value of x. So that gives us then the transformation would be a times the absolute value of 1 over b times x minus h plus k. But we can do a little bit better than this form that g of x is in. So if you recall from section 1 of this chapter, one property of absolute values is that the absolute value of a product is the product of the absolute values. So using this, we can simplify this expression for g, because we notice that there is multiplication going on inside that absolute value. So if I apply that property, we can rewrite g of x to look like that. Everybody okay there? All right. Now, 1 over b is just a number, right? So if I take the absolute value of that number, it just turns into the positive version of that number. And if I multiply a and b or a and 1 over b together, I'd get something like what it's saying is that any transformation that b does can also be done by a. I just multiplied the two fractions together. So I multiply the top by the bottom. 1 times a is a, 1 times b is b. So I have the fraction a over b. Is that okay? Okay. So this gives us then, for absolute value, we don't really need the b at all. So for absolute values, our general transformation is just going to be this. G of x equals a times the absolute value of x minus h plus k. That's one ingredient that we're going to need for our graphing. The second ingredient from last chapter Okay. Also from last chapter, we know that to transform a point on the graph of y equals f of x into a point on the graph of, oh my goodness, g of x equals a times f of 1 over b, we use the transformation xy goes to bx plus h, ay plus k. Now, if we apply this to our situation that we're in with absolute values, we know that so our transformation map is just going to be xy goes to x plus h, ay plus k. So, our question then becomes, if we're just going to be transforming points from y equals the absolute value of x, which points do we use? Well, we're going to use these 3 points. So if I pick x to be -1, the absolute value of -1 is +1. If I pick x to be 0, the absolute value of 0 is 0. If I pick x to be +1, the absolute value of +1 is +1. So if I were to graph the absolute value of x, we have something that looks like this. So whenever we graph an absolute value function, we're going to use these same 3 points to do our transformation every single time. So every time we graph an absolute value function, we're going to be transforming those 3 points. Before we move on and do an example of that, let's take a moment and I want to point out a couple of things about the graph of this absolute value function. So this point here at the tip of the V is called the vertex. And if we talk about the domain and range for this function, for the domain I'm going to identify the furthest left point. So that's here. Since it's pointing left, the x-coordinate's -infinity, but since the arrow's pointing up, the y-coordinate should be +. And then I need to identify the furthest right point, which is it's pointing to the right, the x-coordinate is +infinity. And since it's pointing up, the y-coordinate is +infinity. And since those 2 points are connected, my domain is just going to go from the left-hand x-coordinate to the right-hand x-coordinate. Is everybody okay with that idea? Similarly, let's think about the range. For the range, we're going to identify the lowest point, which is here at the vertex 0, 0. And we're going to identify the highest point, which, well, either end is the highest point, so it doesn't really matter. Let's pick the right arrow. I notice that these two arrows are connected, so my range is just going to go from the lowest y coordinate to the highest y coordinate. So that's 0, positive infinity. Now I know the infinities always get a parenthesis, but a non-infinity sometimes will get a bracket and sometimes will get a parenthesis. In this case, should the 0 be getting a bracket or a parenthesis? Does my function use a point that has a y coordinate of 0? Yes, so I should be getting a Everybody okay here? Okay, let's do an example now. So let's say we want to graph the absolute value function. Y equals -2 times the absolute value of x plus 1 plus 3. So at ingredient number 1, I'm going to remember that I have, this is the general form for any absolute value function. I'm going to use this general form to identify the values for A, for H, and for K. What is my value for A? -2. What is our value for H? -1. Remember that the signs here are opposite. So the H is always the opposite sign of whatever it appears in the equation. And the value for K is +3. Are we all okay with how we identified those values for A, H, and K? Now I'm going to take those values and plug them into the transformation map that we just developed a moment ago. So when I plug in my value for H, I have x minus 1. When I plug in my values for A and K, I have -2y plus 3. So that's the transformation map I'm going to use. What points am I going to transform? These same 3 points that we established earlier. Whenever I graph an absolute value function, I'm going to be using those same 3 key points. So every one of these graphing problems you're going to do in the homeworks, you're going to be using these same 3 key points. So when I plug -1 in for x and +1 in for y, I get the point -2, 1. When I plug 0 in for x and 0 in for y, I get the point -1, 3. And when I plug 1 in for x and 1 in for y, I get the point 0, 1. Is everybody okay with how I did that? Okay. So I have -2, 1, is that point there, -1, 3, and 0, 1. So there's my graph. Stefan?
So wait, how did you, for the first 3 points, how did you get?
This is a value for x. So I plugged it into x. -1 minus 1 is -2. This is a value for y. I plugged it in for y. -2 times 1 is -2, and then plus 3 gives me +1. I just repeated that for the next set of points and the next set of points. Is that okay? Okay. Let's find the domain and range for this function. So to do the domain, I need to find the leftmost point, which is here, -infinity, -infinity, and the rightmost point, which is here, which is at +infinity, -infinity. So my domain is going to be, since the 2 points are connected, the left point's x-coordinate to the right point's x-coordinate, or -infinity to +infinity. Then I'm going to have to identify the highest or the lowest point, which is either one of the arrows. I'm going to choose the left arrow. To the highest point, oops, -1, +3. I'm going to go from the y-coordinate of the lowest point to the y-coordinate of the highest point. So that's -infinity to 3. But I remember the numbers can have brackets or parentheses. For 3, I should have a bracket because there is a point on my graph. The coordinate is 3. It's right here. It was one of the ones that we plotted even. Is that okay with you guys? Can we do a little bit better with this domain and range? So let's think about this for a minute, because all we're doing is transforming that function y equals the absolute value of x that we had from before, right? Recall, what does a do? What kind of transformations does a do? One of the transformations a does is it reflects across the x-axis, right? Is that going to change having an arrow pointing to the left or pointing to the right? If I just flip it upside down? No, I still have an arrow pointing left and I still have an arrow pointing right. Okay, the other thing that the a does is it does a vertical stretch or shrink. Is like making it taller and skinnier or wider going to affect an arrow at the left end and an arrow at the right end? No, they're still going to have those arrows there. What does the h do? Moves the graph left and right, correct? Is that going to change arrows at both ends? No. What does the k do? Moves it up and down? Is that going to affect arrows at both ends? No. So what does that tell me then about the domain? It's always going to be -infinity to +infinity. For every absolute value graph. Now let's think about the range. So we've looked at 2 of these, correct? We've had 2 options. Either we've gone from the lowest point to the vertex, or we went from... Do you agree with that? Okay. So how do we know when the graph is going to be pointing up like a V or down like a wedge? which A, H, or K is going to control which way the graph is going to open. So if this is our original here, if we reflect it as what's it going to look like? A wedge, right? Everybody agree with that? So there's two things that the range is going to depend on. It's going to depend on the sign of A. So if A is positive, one thing is going to happen. Or if A is negative, something else is going to happen. Is everybody okay with that? So if A is positive, we're going to have a V. So we're going to go from the y coordinate of the vertex, which is the K value, up to positive infinity. And if the A value is negative, the graph is going to point down. So we're going to go from negative infinity up to the y coordinate of the vertex, or the K value. So you can do the domain and range, whichever way you feel comfortable. You can do it by inspection like we've done before. Or, if you remember this set of criteria, you can do it without really even looking at the graph at all. If you just look at the equation and pick out the values for A and K, you can write down the domain and range without having to even draw the graph at all. Is that okay? Let's do one more graphing example and then move on to the next topic. Okay with that? Okay. So let's say we want to graph y equals negative absolute value of x plus 4. First thing we do is we identify our values for A. What's my value for A in this problem? Negative 1. Very good. And what's our value for H? Negative 4. And 0. So because the H's and K's are being added or subtracted, if you don't see an H or K, those values are 0. Because the A and B are being multiplied, if you don't see an A or B, then we're 1. Is everybody okay there? Now we can write our transformation map. And then what points are we going to transform? The same 3 points every time we graph an absolute value function. Negative 1, 1, 0, 0, and 1, 1. Is everybody okay to there? Okay. We'll plot our points then. 1, 2, 3, 4, 5. Negative 1 down. So negative 5, negative 1. Negative 3, negative 1. So there's my graph. And then what would the domain be for this function? Good. Always that for absolute value functions, every single time. And then what would our range be? Well, our range depends on our value for A and K, right? So since the A is negative, I know we're going to start at negative infinity and go up to K. Or you could have done it by inspection by looking at the graph and doing it the same way we did the previous chapter. Either is fine. I think that knowing the rule and using the rule is a little bit faster, but whatever works for you is fine. Do we feel okay about graphing? Should feel pretty familiar. It's exactly the same graphing process that we used from last chapter, and we'll use the same graphing process for the majority of our time here. So the graphing should remain pretty similar. The only thing that's going to change are the key points involved and the form of the transformation, but it's going to be the same procedure. It's going to be graphing absolute value inequalities in two variables. Now I put this in two variables part at the end to differentiate this from when we graphed an inequality on the number line like we did in the previous section. Here we're going to be graphing something that looks like this. So when I say in two variables, it means that I have an x and a y in there. So it's something we would graph on the xy axis. Okay? And I'm not going to do any explaining here. We're going to dive right into an example because the majority of this example, or the majority of this process, is exactly the same as what it was when we graphed a absolute value function. There's just two little things at the end that we need to do differently. Or I wouldn't really even say differently. I would say in addition. And we'll just kind of cover those when we get to them. Okay? So I'm just going to kind of explain this process inside of this example. So we're just going to start by pretending that really we just have y equals instead of greater than. So if I wanted to graph y equals, well, I start by identifying A for h and for k. And then I make my transformation map. And then I transform my same three key points. Points I get, -2, -5, -1, -3, and then 0, -5. And then I'm going to plot these three new points. Two, 1, 2, 3, 4, 5. So I have -2, -5, -1, -3, 0, -5. But now I'm going to stop. Before I do anything else, after I've plotted my 3 points, I'm stopping. Because this is the place where there's a little bit of difference between these two. For an inequality, there are two things we have to worry about. So the first thing is for a greater than or a less than, we're going to draw a dashed line. And for a greater than or equal to, or a less than or equal to, we're going to draw a solid line. Now our problem was a strict greater than, so this problem we need to draw a dashed line. Are we all okay there? The second thing is we have to worry about the shading. So for a less than or a less than or equal to, we're going to shade below the line. And for a greater than or equal to, we're going to shade above the line. So this example was a greater than. So the shading I'm going to do is above the line. So I'd be shading like this part of my graph. Is everybody okay with that? So these two are the two differences, or the two additional things we need to do for an inequality versus just an equation. So you have to remember which kind of line to draw, solid or dashed, and which way to shade above or below. But that's it. Let's do one more. Sound good? Okay. So identify our value for H and for K. We'll write our transformation map. And then transform our three key points. Again, every time we graph an absolute value, we're using these same three key points. Once we have our 3 points, I'm going to draw our graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So -5 and 6.5. -4 and 6. And then -3 and 6.5. And since we are, then now we go back and look at our inequality. This was a greater than or equal to, so we're going to draw a solid line because it's an or equal to. And because it was greater than, we're going to shade above. No. So the inequality is telling us which direction to shade. So if the inequality is a greater than or equal to, then we shade above. So if this was like pointing down, shading above would be still above. Is that okay? Okay. To do with like what direction the V is pointing. It has to do with the inequality symbol only. What do you guys think on this? Not bad, right? Pretty much the same thing as what we had just done. There's two little additional things, but they're not really difficult to do, right? You just have to remember the rule and look at the inequality symbol. And like, that's pretty doable. All right. Last topic is modeling absolute functions. So the idea here about modeling, we're talking about going from a graph back to an equation, or some information about the graph and going back to an equation. And everything we need to do a problem like this, we've already developed. So let's just kind of go walk through a couple of examples to kind of show you guys what to do here. But there's nothing involved here that we need to kind of like, all the tools that we're going to use we've already kind of talked about. So I don't think we need to do much there. So let's get a nice, neat looking graph. That's not what I asked for. Try it again. Let's make that big so it's easier to see. Okay. So we want an equation for the absolute value function that represents this graph. So what we want is something of the form y equals a times x minus h plus k. Everybody okay with that idea? In order to write the equation, we need three things, a for h and for k. Everybody okay with that idea? Okay. To do that, we're going to need two things. The first tool that we're going to use is that the vertex is equal to h comma k. So if I go to my graph, I can identify my vertex, which is this point right here. That's the point -2, 5. So I can immediately say that h is -2 and k is +5. Everybody feel okay doing that? That's 2/3 of the way done right there. And we didn't have to do anything tricky. That's pretty nice, right? The last piece is we're going to use any and the h and k to solve for a. So I'm going to then look at my graph and find any other point. When looking for this any other point, the big thing that I want is to something that I can reasonably guess has integer coordinates to it. So being able to read off a point on the graph accurately is really important. So for example, I wouldn't want to pick this point because I'm not sure what its x-coordinate is, right? It's somewhere in between -3 and -4, but I can't tell exactly what it is. That would be a bad choice. This point over here would be a good choice because I can tell exactly that this is the point 0, -1. Is everybody okay with the idea there? Okay. So let's say we use this one. It doesn't really matter which one we pick, but you want to pick one with whole number coordinates. So what I have here is an x and a y, right? That's what a point is. So if I go back to my equation, I have an x and a y, and I have an h and a k. If I plug all of that stuff in, I'd have -1. Well, let's write it above so we gotta tell what we did, maybe a little bit easier. Equals a times 0 minus a -2 plus 5. And now we can solve for a. So if I subtract 5 from both sides, I get -6. 0 minus a -2 is +2, and the absolute value of +2 is 2. So that leaves me with 2 times a, or just 2a. And if I divide then both sides by 2, I get that a is equal to 3. So my final answer I'd write is y equals -3 times, instead of writing minus a -2, I just wrote it as plus. You could leave it as minus a -2 and it's still fine. I would not mark that wrong. Is everybody okay with how we did that? Does this remind you of anything? Kind of looks, okay. I meant the process, not the picture, but sure, the picture does look a little like a Christmas tree. Ben?
Does that say +5 at the end?
Yes. Does this remind you at all of when you wrote the equation for a line in Algebra 1 and you had to plug in the x and y to solve for the y-intercept to find the b? Feels a little bit similar to that, right? That's a modeling question where you're given some information about a graph and asked to produce the equation. It's the same skill. It's a different function, so the procedure is a little bit different, but it's the same general idea. Okay? Let's do one more, and then we'll finish for today. Sound good? The other situation is if we give you some information. So let's say we did that. So let's say that we want to write the equation for the absolute value function, whose vertex is 3, 5, and we pass through the point -1, -5. Is this really any different than the previous problem? No. The only difference here is that instead of having to read a point off our graph, we're told the points expressly. So right, I can tell that the h and k is 3 and 5 because I know the vertex is 3, 5. And then using the other point, I can fill in the values for x, y, and h and k. Say -5 is equal to a times the absolute value of -1 minus 3 plus 5. So to solve for a now, I'll subtract 5 from both sides. And -1 minus 3 is -4. The absolute value of negative 4 is positive 4, and a times 4 is just 4a. So far, so good. If we divide both sides by 4, we'd get negative 10 over 4. But you can reduce that fraction down to 5 over 2. So we'd write y equals negative 5 over 2, absolute value of x minus 3 plus 5. What do you guys think? It's all right? Good. Okay. So for homework, I have 4 graphing problems. That's already on the content library. I have 4 graphing inequality problems, already in the content library. And 4 modeling problems, already in the content library. This was actually the last topic that we were going to cover in Chapter 2. So my plan for this week is to have Wednesday be a kind of general work day. You can work on any of these homework assignments. I've also made a review for Chapter 5. We'll take general questions and then give you guys the rest of the time in class to work on the review or the other homeworks, wherever you're at. And then the plan would be to try to take that chapter test on Friday. Does that seem reasonable? I mean, it's cool. Okay. Yeah, this Friday. Again, Wednesday is all yours. You know, we'll answer questions and you guys can work on whatever you need to. We'll talk about the test format and stuff then too. But that's my plan. Unless you guys give me a good reason why we need to push it to next week, other than you just don't want to do it this week, which is not exactly a great reason. That was your only reason. Okay. Well, this one should be much easier than the previous test, and history tells me such, anyways. Yeah, so the homework would still be due Sunday at midnight. Yep. And all that stuff is, I think all the details are up to date on PowerSchool. You're going to roll your ankle walking in those shoes, my man.